Energy, value and uses. All living things need energy. The energy makes things grow, enable us to do work, keep human beings and animals warm, and sustain life. Moving objects use energy. When work is done, energy is changed from one form to another. This energy can be defined as the ability or capacity to do work. The SI unit of energy is joules. Classes of energy. Energy is classified into general types: kinetic energy and potential energy. Kinetic energy. This is the energy an object has because it is moving. The faster the object moves, the greater the kinetic energy. This energy can be released by stopping the object. A student having a mass of 35 kilograms and running with a speed of 10 meters per second. What is her kinetic energy? Mass, which we abbreviate as M, is equals to 35 kilograms. The speed, which we abbreviate as V, is equals to 10 meters per second. Kinetic energy, Ke, is given by the formula half mass times velocity squared. This will be equals to half times 35 times 10 squared. This is equals to, this is half times 35 times 100. This will give us, so this will give us 1750. So 1750 joules. Kinetic energy is a type of energy, and energy is measured in joules. So our Ke will be 1750 joules. Potential energy. It is the energy stored in an object because of its position or shape. Potential energy exists in two forms. A. Gravitational potential energy. It is the energy stored in an object due to its position in the Earth's gravitational field. The energy increases as the object is raised above the Earth and decreases when the object falls. Elastic potential energy. This is the energy stored in an elastic material. A student having a mass of 35 kilograms is raised to a height of 3 meters above the ground. What is his potential energy? Mass equals to 35 kilograms. Height above the ground is equals to 3 meters. Potential energy is given by the formula mass times acceleration due to gravity times height. We take G to be 10 meters per second squared. So in this case, our potential energy, PE, will be equals to 35 times 10 times 3. This will give us 1050 joules. Material. Forms of energy. Energy is divided into many forms, such as mechanical energy, heat energy, electrical energy, light energy, sound energy, chemical energy, nuclear energy, and solar energy. 1. Mechanical energy. This is a sum of the potential energy of an object. 2. Heat energy. This is the energy that flows from one object to another due to their difference in temperature. When hot objects cool down, the atoms lose energy. This energy is known as heat energy. It can be obtained from fire, lighted bulbs, sun, friction, etc. 3. Electrical energy. This is the energy due to the motion of charges, that is electrons or ions, in conduction. 4. Light energy. This is the energy which is detected by the eye, example, or energy that enables us to see. This is energy given off by hot objects when they shine. It can be obtained from fire, lighted bulbs, sun, etc. 5. Sound energy. This is energy produced by vibrating objects. Sound is produced when we play drums, talk, shoot a gun. 6. Chemical energy. This is energy stored in chemical bonds. It is released in chemical reactions such as burning. It is energy stored in food, petrol, gas, wood, etc. 7. Nuclear energy. This is energy stored in the nucleus of atoms. It is released when an object splits or breaks down or explosion of bombs such as atomic bombs. 8. Solar energy. This is energy gotten from the sun. This energy is used by plants to produce their food during photosynthesis. Sources of energy. An energy source is simply where energy comes from. Almost all the energy used on Earth comes directly or indirectly from the sun. About 99% of the world's energy can be traced back to the sun. Plants use solar energy in the process of photosynthesis to produce their food. Animals get their food from plants. Hence, food is a store of energy from the sun. Uses of energy. Energy from the sun can be used for food preservation, drying of grains. Solar devices. Solar cells convert solar energy directly to electrical energy. They are used in some calculators, lamps, street lights, etc. Solar panel, used at home for heating. It converts solar energy to heat energy used for heating water. Advantages of solar energy. Solar energy is a renewable energy source. It does not pollute the environment. It is free. Renewable sources. These are sources of energy that do not get finished. They can be used over and over. Example, sun, wind, water, geothermal, and biomass. Non-renewable energy sources. These are energy sources that cannot be replaced when used. They get finished, that is, exhausted in their supplies. Example, wood, fossil fuel. Fossil fuel is any fuel formed from the remains of ancient plants and animal life. Daily use of energy, that is energy conversion. All our daily activities make use of energy. Example, when cooking, playing, watching TV, driving a car, climbing a tree, etc. The use of energy involves the conversion of energy from one form to another. For example, when a battery is connected to a bulb, chemical energy in the battery is converted to electrical energy, which is later converted to light and heat energies. That is, when driving a car, chemical energy in the fuel is converted to electrical energy, which is later on converted to kinetic energy, heat energy, sound energy, light energy. When a ball is running, electrical energy stored in the muscles is converted to kinetic energy, heat energy. From the above examples, we can say that energy is not created or destroyed, but it is just being converted from one form to another. Therefore, the principle of conservation of energy states that energy can neither be created nor destroyed, but can be converted from one form to another. A device or instrument that converts energy from one form to another is called a transducer or a converter. Some examples include wind plants, batteries, bulbs, solar panels, electric heaters, electric iron, etc. Transmission of energy. Heat energy can be transferred from one place to another in three ways: conduction, convection, and radiation. A. Conduction. Conduction of heat energy. Conduction of heat